All right, so here we have our second argument, and it's pretty complex. The conclusion is a conditional, just if x and y. And it's a simple conditional, so that's good. The second premise here is a conditional, but it's got some stuff inside it. It has a negation in the antecedent, a conditional, and then a negation in the antecedent. So this is going to be pretty complex. And this is an and of two conditionals. Okay, so definitely the conclusion is the simplest. So that's where we want to start. We want to start by doing whichever column is the simplest, because it's going to give us the most information the most quickly. So let's start with the conclusion column and go down this row, or this column. So if x then y, well, if the antecedent is true and the consequent is true, then the conditional is true. Do we know whether or not this row is okay or bad? Yes, we know that the row is okay because it has a true conclusion. Let's go to the next row. Conditional, if true then false, false. Do we know whether or not this row is okay or bad? We don't know. It might be bad. It's going to be bad if both the premises are true, but if either of the premises are false, it's okay. So right now we don't know. We're going to have to come back to it. But we'll keep going down. So, okay, the conditional, if true then true, the whole thing is true. This row is okay because it has a true conclusion. The conditional is if true then false on this row, so it's false. We don't know about this row. If false then true, if false then true is true, this row is okay. If false then false, the conditional is true, so the conclusion is true, so the row is okay. If false then true, true, the row is okay. If false then false, true, the row is okay. So we know that the first row, the third row, and the fourth through eighth rows, all of these are okay because all of those are okay because their conclusions are true. We know they're all true. So there are two rows we don't know about, the second row and the fourth row. Either of these might be bad. If those are both true, the row is going to be bad. If those are both true, the row is going to be bad. So that's what we're going to have to check. So let's actually, it's going to be, if we look at let's see which of the first and second premises are more complex, which tree is going to be easier to handle. So this row, well, there are two conditionals we have to calculate. This row, so here we just go 1, 2, 3. There are 3 boxes there. Here we have 1, 2, 3, 4. So this is a bigger tree. So let's try this one first. Let's do this premise 1 row first because it looks like the tree is smaller. Okay, so we have if true then true. That's true. This is the other conditional, and it's if true then true. So that's true. This is a conjunction. Both the conjuncts are true. It's true. So do we know about this row? Might be true, might be a good row, might be a bad row, don't know. Let's finish with premise 1. We have so we're going to skip to the fourth row because we know the first row is okay, third row is okay, and those rows are okay. So the only two rows we care about are the second and fourth. So we're doing the premise 1 column, we're calculating its truth values, but the only rows we don't know about are the second and fourth rows, or second and fourth rows. So we're only going to calculate the value for premise 1 on row 2 and row 4, because the other rows we already know they're okay, so we don't care what truth value premise 1 has on those rows. Okay, so going to the fourth row, we're going to calculate the value of premise 1 on the fourth row. If true then false is false. If we remember this is a conjunction, then we think, oh, well, if a conjunction has a false conjunct, then it's false. So we know that the conjunction is false just given that this is false. We don't care about the truth value of this conditional. Actually, it's true, but it doesn't matter. Even if whether this is true or false, the whole conjunction is false because the left conjunct is false. Okay, that tells us this row is okay now because it has a false premise. So the only row we don't know about is the second row. We know the first row, the third row, and the fourth through eighth row are all okay because they have a true conclusion. Or the fifth through eighth row. The fourth row is okay because it has a false premise. So the only row that might still be bad is the second row because it has the only premise we know about is true and the conclusion we know is false. So if this premise is true, then this row is going to be bad and the argument is invalid. If the premise here on this row, if premise 2 is false on this row, then this row has a false premise and so the argument is okay. Or the row is okay, so all the rows are okay, so the argument is valid. So let's find out whether or not premise 2 is true or false on this row, and so whether or not this row is okay or bad, and so whether or not the argument is valid or invalid. Okay, so let's see. Well, we'll just start from the bottom. So there's x. So negation x is false because x is true. Here we have a conditional, false arrow true. False arrow true is true. Okay, so we have a conditional whose consequent is true. Oh, well, if we don't remember this, it turns out that if you have a conditional whose consequent is true, then the conditional is true. But if we didn't remember that, we could go and say, okay, what's y? Y is false, so negation y is true. So we have true arrow true, which means the whole thing is true. So, okay, what does that mean? Is this row okay or is it bad? Well, we have premise 1 is true, premise 2 is true, and the conclusion is false. So all the premises are true, and so the conclusion is false, and so this row is bad, and so the argument is invalid. And so the way we say that is we say the argument is invalid. If we check it, the computer program is going to complain that it doesn't say incorrect, it says incomplete. It's incomplete because we have to say which row is bad. We have to check the row that's bad. So we will check the second row because that's where the bad row is. We'll check it again and it says correct. When an argument is valid, all the rows are okay. You don't need to check any. But when it's invalid, there's a bad row and you have to check the row which is bad. Just like with tautologies, you have to check the row where the tautology, when you're checking for whether or not a sentence is a tautology and you decide it's not a tautology, you check the row on which the sentence is false. Here, when the argument is invalid, you check the row on which the premises are true and the conclusion is false. Okay, good. So in the next video, I will take a look at one last example problem.